Hello students, very good evening. This is Mayuras More, your chemistry tutor. I welcome you all to NEET Chemistry. Now this is the very first session. Now this is going to be very first session of our NEET Chemistry of Isomerism. Okay. In the earlier we had finished a chapter called GOC, General Organic Chemistry. Then we have covered a chapter called IUPAC Nomenclature, where we have seen how the different types of compounds being named. Okay. Now we're gonna see the next part of it, which is isomerism. Okay, isomerism is one of the most important part of your organic chemistry. There have been so many questions asked on this, and this is, I won't say confusing, but yes, it might confuse you in the exam time because you are having a very small time to solve each questions. Okay, so we're gonna discuss some of the ideas. Okay, we're gonna discuss some of the tricks for it. So on that note, let's begin the isomerism session number 1, NEET Chemistry. Let's begin. So, what is isomerism now? See, isomerism. So, what is the meaning of this iso? See, this iso meaning means equal. Iso means equal or something which is equivalent. Okay, equal iso. And mer means form. So, equal form, something which has an equal form. Okay, so that is what the definition says. Okay. That means, I mean, what I would say, that is what the word says. Isomerism, equal form. Okay, but that is not the exact meaning as such. Okay, we're going to see what is it. See, if there are two or more compounds which are having same molecular formula. If there are two or more organic compounds, I'm not saying only organic, it could be any compound for that matter. If there are two or more different organic compounds having same molecular formula, and so if they have same molecular formula, they might also have a same molecular weight, right? So two or more organic compounds having same molecular formula, same molecular weight, but different physical and chemical properties. Different physical and chemical properties. Such compounds are called as isomers. And the phenomenon is called as isomerism. That means there might be two or maybe more than two compounds which are having same molecular formula. Now, if they are having same molecular formula, obviously they are going to have the same molecular weight, right? But they might have a different physical and chemical properties. Chemical property doesn't change as always, okay, but physical properties, yeah, physical properties are going to change every time, that's for sure. Okay, physical property, for example, density, viscosity, okay, then vapor density, all of those. Okay, chemical properties may or may not change, we will see that. Okay, so such a phenomenon is called as isomerism. Okay, so I hope you must have understood the definition really well, or let me give you a quick example of it. We're gonna see it anyways, but I'll give you a quick example of it. See, I'll give you one example. Suppose you have a C5H5OH. Not exactly C5H5, just a sec. Oh, let me give you an example. C2H5OH. Now, what is this? This is an ethanol. This is an ethanol. If you look at its molecular formula, what is its molecular formula? It is C2H6O. Similarly, you got one more compound which is having a same molecular formula, CH3OCH3. This is also C2H6O. But this is ethanol. This is what? This is dimethyl ether. This is dimethyl ether. Now both of them are just the same compound. Okay, same molecular formula, but their functional group is completely different. Ethanol, people use ethanol for drinking purposes, and ethanol can also be used as a solvent for different kind of medicines. Ether, no, you can't use ether as a solvent in a different medicine, and people don't consume ether also. Ether basically is an anesthetic reagent. It is a anesthetic reagent. Okay. So it is anesthetic reagent. Okay, so people can consume it. Your dimethyl ether actually used for anesthetic purposes. People can drink it. If people drinks it, they might die. Okay, so that is a thing that is one of the very beautiful thing of isomerism. Okay, so chalo, moving ahead with this now. So what are some of the types of isomerism? Let me rub this down first. Oh, what is happening? Anyway, it's not working. So yeah, so what I was saying, isomerism. What are some of the types of isomerism? See, there are two types of isomerism: structural isomerism and stereoisomerism. Structural isomerism and stereoisomerism. Stereoisomerism is very large. We're gonna discuss stereoisomerism in the upcoming sessions. Okay, but in today's session, we're gonna discuss the structural isomerism. What is your structural isomerism? Okay. So yeah, so structural isomerism we're gonna discuss, that's for sure today, and stereoisomerism. Stereoisomerism we will see in the upcoming session. So there are different types of structural isomerism. What are those? Stereoisomerism also has types. Okay, it also has types, but we will discuss that. So whatever types you are seeing right now, these are the types of structural isomerism: chain isomerism, position isomerism, ring chain isomerism, functional isomerism, metamerism, and tautomerism. Okay, so we're gonna see each one of them one by one. Okay, so chalo, moving ahead with this, the very first, chain isomerism. Now, what is chain isomerism? See, these are the compounds in chain isomerism. These are the compounds which have same molecular formula. They are having same molecular formula, same functional group. Their molecular formula is exactly same. Functional group is also same. They are having same position of functional group. So same molecular formula, functional group is same. The position at which functional group is attached is also same. Now it could be the position of functional group. Sometimes it might be the position of your multiple bond, okay, or substituent. But different arrangement of a carbon chain. Different arrangement of a carbon chain. Basically different parent name. What? Different parent name. Now, where do we give the parent name on? We give the parent name based on the chain, longest chain. So that longest chain, that parent name is going to be same. Okay, but the functional group, the position at which a functional group is attached is same. The position at which double bond is situated is also same. Okay, but different arrangement of a carbon chain. I would rather say chain isomerism is what? These are the compounds having everything same, but the longest chain. Remember, we had discussed in IPAC nomenclature. What do we discuss? That we select the longest chain whenever you are naming the compounds, right? So that longest chain is of different length. That longest chain is of different length in a chain isomerism. That is what the chain isomerism is all about. Okay, now let's see some of those examples. Now, firstly, where do we have where does this chain isomerism starts from? Does it start from a carbon having a two? Does it start from a compound having two carbon atom? Can we do that? Let's see. Suppose you are having CH3, CH3. Now, is there be any arrangement of this CH3? Is there any possible arrangement apart from this? No. So ethane cannot show any isomerism. Secondly, suppose if you have a CH3, CH2, CH3. Now what is this? This is your C3H8. Just a sec. This is your C3H8. It's not getting. Okay, so this is C3H8. Now, can we have a different arrangement for this? Can you do it? No, it can't have any other arrangement. It can be only arranged like this. See, like this. So this is your CH3. This is your CH2. This is your CH3. You cannot have any other arrangement other than this. So this also cannot show chain isomerism. Then, which compound can show chain isomerism? Let's go to the fourth compound. CH3, CH2, CH2, CH3. Now, can we have any other arrangement apart from this? Let's try. CH3, CH, CH3, CH3. See? So this is a different arrangement overall. You can see here. See? In the longest chain, you got how many carbon atoms? 1, 2, 3. Right? Here, how many carbon atoms do we have in the longest chain? 1, 2, 3, and 4. Right? 1, 2, 3, 4. And what is the molecular formula? So this is C4H10. What is this? 1, 2, 3, 4. Again, this is also C4H10. So that means what? These compounds are chain isomers. These are chain isomers, right? Because here, what is the name of this compound? If you want to name this compound, want to name it, it will be your N-butane. When do we write N? N means normal. N means normal. It's a normal butane, right? And how do you name this compound? This can be named as butane. Why? Because in the longest chain, you got only 3 carbon atoms. 1, 2, 3. And this will be your what? Substituent. This will be your substituent, right? Oh, what happened here? So as just a sec. So CH3, CH2, CH2, CH3. This is your N-butane. Now you have a CH3, CH, CH3, CH3. What is this? This will be named as 2-methyl propane. Isn't it? This will be named as 1, 2, 3. At the second position, you got the methyl, right? So 2-methyl propane, that's how you name it. Because in the longest chain, you got 3 carbon atoms. Here in the longest chain, you got how many carbon atoms? 1, 2, 3, 4. Right? So 1, 2, 3, 4. But both of them are having same molecular formula, C4H10. C4H10. So they are what? They are the chain isomers. Okay? That's how. So basically, chain isomerism starts. It starts from 4th carbon for alkenes. Okay, for different compound it's different. I'll show you. Basically, chain isomerism starts from 4th carbon only. Be it alkane, be it alcohol, you take anything. Okay, doesn't matter. Now we're gonna see the different compounds. Okay, so we had seen already 4 carbon atoms. Now let's see 5 carbon atoms. So C5H12. How do you arrange this now? So 1, 2, 3, 4, 5. Now this might sound confusing to you. You might just say, what is this? See, this point, basically this is carbon. So here you got carbon, 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 carbon. This is called as bond line formula. This is called as bond line formula. Okay, and how do we arrange this? See, So you can see this carbon is attached only with 3 carbon atoms, right? So this carbon is attached with only 3 other carbon atoms. That means there must be 3 hydrogen here, CH3, right? Similarly, if you look at here, here this carbon is attached with this carbon and this carbon. That means this carbon there would be 2 hydrogen, CH2, right? Similarly, this carbon is attached with two other carbon atoms. That means there must be 2 hydrogen here, because valency of carbon is how much? Valency of carbon is 4, right? Similarly, this carbon is attached with 2 other carbon atoms. That means there must be 2 hydrogen here, H2. And lastly, this carbon again is attached with only this carbon atom. That means there must be 3 carbon atoms there. So that's how CH3, CH2, 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 CH3. That's how you arrange the pentane. That's how you arrange the pentane, right? So that is the one possibility. Now, what about a second possibility? See, the second possibility is this. Just remove this part and attach it here. See, this is the second possibility. How do you name this compound? You would name this compound as N-pentane. How do you name this compound as? Now this is your substituent. So 1, 2, 3, 4. This is your substituent. So you would name this as 2-methyl butane, right? 2-methyl-butane. That's how you should name it right now. So that is one. This is one structure. This is another structure. Both of them are different structure. 1, 2. Can we arrange one more structure in this? Yes, we can. Let me show you. See here. 1, 2. 1, 2, 3. Right. Then you got 1-methyl, 1-methyl. See, so if you start counting here, how would you count it? So if you have to count here, it will be 1, 2, 3, right? 1, 2, 3. This is also methyl. This is also methyl. So if you have to name it, how would you name it? It will be 2, 2 dimethyl propane, right? 2, 2 dimethyl propane. Now look, if you look at the molecular formula of all this compound, it is same. C5H12. Look at this. CH3, CH3, C, CH3, CH3. So basically there are 4 CH3, which makes it C4H12, and there is this single carbon. So basically this is also C5H12. So you have 1, 2, and 3 isomers for the pentane. So this is basically pentane. So for C5H12, you got how many isomers? You got 3 isomers. Okay. Now what we'll do? We will increase one more carbon, and let's see how many isomers does it shows to you. See, the next is C6H14. So C6H14. Okay. Now the very first isomer is what? It is going to be N-hexane, right? 3, 5, 6. Arey yaar, what is happening here? Just a sec, okay? So yeah. So C6H14 14. See, the very first isomer, that is what we're going to have here is this one. How many carbon atoms do we have here? 1, 2, 3, 4, 5, and 6. How do you name it? You would name it as N-hexane. It will be named as N-hexane, straightforward, right? Now, secondly, what do? You take one of this segment and just attach it here. Then you will get the second isomer. See, this is your second isomer. Now, how would you name it again? 1, 2, 3, 4, 5. How would you name it? 2-methyl. How many carbon atoms are there in the longest chain? 5. They are going to be different. That is what the chain isomerism is all about. Every isomer is going to have the same number of carbon atoms, same number of hydrogen atoms, but the number of carbon atoms in the longest chain, they are going to be different. And that is why the name came, chain isomerism. Okay. So 2-methyl pentane. That is what the name of this compound is. Now what do? How can we get a third structure? Just plug this methyl and attach it to the third position. What do we get? See, 1, 2, 3, 4, 5. What do we get now? 3-methyl pentane. It is still pentane, isn't it? 3-methyl pentane. At the third position, you got a methyl here. 3-methyl pentane. That's how we name this. Okay, so you got the 3 isomers. This is first one, this is your second one, this is your third one. Now, what is the fourth one? What can we do? Now, you might say, sir, we can plug this and attach it here. No, if you do that, it will be same as the second. Why? Because you always start counting from that end where you have a more number of branches. So if I plug this methyl, if I attach it here, you will start counting from this end. 1, 2, 3, 4, 5. Then it will be again 2-methyl pentane. So it will be same as it was earlier. Okay, it is not going to be different. So we need a different compound. Remember, always, sometimes 2 or more compound might look different. Okay, so here is the catch. How to identify whether 2 different isomers are there or not? So to check that, you need to name them in an IUPAC way. If their IUPAC names are different, that means both the compounds are surely different. If their IUPAC names are same, if their IUPAC name is same, and no matter how different both the compounds look like, they must be exactly same. Let me give you a quick example. Look at this, L. Now, do you think both of these are different or same? What do you do here to check their names? So see, you do the start counting here. 1, 2, 3. 3 carbon atom. What is it? It's a propane, right? 3 carbon atom. It's a propane. Now here again, 1, 2, 3. What is it? It is also propane. So both of them are same. They are looking like different, but their IUPAC name is exactly same. Okay, so always remember this. Just name in an IUPAC way, you will come to know whether both the compounds are same or different. Okay, now we got a 3 isomers. Now what do? How can we get a fourth? Now in the earlier part, what do? We remove this one part, we attach it here. Now we're gonna do what? We're gonna remove 2 parts. Basically, see, like this. 1, 2. Now, how would you name it? It will be like 1, 2, 3, 4. How do you name it now? 2,2 dimethyl. 2,2 dimethyl butane. Isn't it? It's different, no? 2,2 dimethyl butane. So these compounds are different. Now, what do we do in the next structure? So this is your 4th isomer now. Now you will plug this and you will attach it here. See? Here, here. So 1, 2, 3, 4. So what do we name this now? 2,3 dimethyl 2,3 dimethyl butane, isn't it? Its name is different, so this is your fifth isomer. So that is how you can get the different isomer. Now for the butane, we had how many? We got a 2 isomer. For pentane, we got 3 isomer. For hexane, we got how many? We got the 5 isomer. Can we have any other possibility apart from this? If we do, please comment. Please comment. Please write it in the comment section. Okay, if you get to know any other possibility apart from this for the N-hexane. Now, for the other compounds, for example, C7H16, C8H18, there are so many isomers for them. But I am going to leave that to you. Now you need to solve it and you need to tell me how many different kinds of isomers are there possible for this heptane and the octane. Okay, we have seen it till the hexane. That is what the chain isomerism is all about. Okay, chalo, moving ahead with this now. So the next one is your position isomerism. What is happening here? Yes. So yeah. Now the next one is position isomer. Now what about these position isomers? What are those? See, the compounds which have same molecular formula. Now again, see, whenever you are saying isomerism, the compounds are going to have a same molecular formula anyways. Okay, that is not going to change at all. But the other things are going to change. So the compounds which have same molecular formula, same functional group, same parent carbon chain. Now, in the last isomerism, what did we see is that the size of the chain was different. The length of the chain was different. Okay, that is why we were calling it as a chain isomerism. Here, the size of the chain is same. Size of your parent carbon chain is same. Molecular formula is same. Functional group is same. Everything is same, but different positions of the functional group. The position of your functional group is going to be different, or multiple bond or substituent, whatever it is, their positions are going to be different. That is what it is all about. Okay, so now let's see some of those examples. Let's see this. See this compound, how do you name it now? It will be but 1-ene, right? What is happening here? Just a sec, okay. So yeah, now see, you got a double bond here. Now how would you name this compound? So whenever you have a double bond, what do? You start counting from this position. 1, 2, 3 and 4. What is the name of this compound? It will be named as but-1-ene. It's a but-1-ene, right? Now let's see the other compound. See this compound. Now you got a double bond here. How would you name this compound now? 1, 2, 3, 4. The name would be but-2-ene. in. It will be butene, isn't it? Now, if you look at the number of carbon atoms here, how many of them? C4H8. How many of them here? C4H8. But what is the position of double bond? The position of double bond here is first. The position of double bond here is second, isn't it? So that is how the position isomerism is all about. That is what it is all about. Okay, I'll give you so many examples apart from this now. Let me show you now. See this compound. At the first position, you got the OH group now. Now, how would you name it? 1, 2, 3. It will be named as 1-propanol. It will be named as 1-propanol. Now, you can attach the OH group at the second position also. How do you name it? 1, 2, 3. You would be naming it as 2-propanol. 1-propanol, 2-propanol. If you look at the molecular formula, see, you got 3 carbon atoms here, 2 carbon atoms here, and 1 carbon. Here also you got a CH2. So if you want to name it, it will be like C3, 3, 5, 7, 8. Yeah, C3H8. Both of them are C3H8. Okay, but look at the OH group is attached at the first position here. Here the OH group is attached at the second position, isn't it? So their positions are different. That's how the position isomerism is all about. Now we want to see the different structures. Let me give you a quick example of this. Yeah. Now we can take the example of this C4H10, yeah, C4H8Cl. Okay, so basically this could be geminal dihalide or it could be vicinal dihalide, but we will see that now. See, 1, 2, 3. Now you can attach chlorine here and here also. What would be the name of this compound now? 1, 1, 1 dichlorobutane. 1, 1 dichlorobutane. Okay, 3, 5, 7 and 1. Yeah, 1, 1 dichlorobutane, or get this chlorine. What do you name this compound now? 1, 2 dichlorobutane. 1, 1 dichlorobutane. 1, 2 dichlorobutane. What can we have apart from this? Chlorine here, chlorine here. Now what is the name of this compound? 1, 3 dichlorobutane. And lastly, you can have chlorine here and chlorine here. Now what do you name this compound as? See, 1, 2, 3, 4. 2, 3 dichlorobutane. See, that's how all of these 4 compounds are what? All of these 4 compounds are position isomers. They are position isomers. Their positions are completely different. Look at this. Every compound is having a different name. 1, 1, 1, 2, 1, 3, 2, 3. Can we suggest any other compound apart from this? If you do, you can please tell me in the comment section. If is there any compound apart from this? If it is there, you can tell me. Okay. But as per my knowledge, for this particular compound, there are only this many compounds only. There are not more than that. Okay. So that is how this position isomerism works. Okay. Whenever the molecular formula, or as the compound starts having more and more number of atoms, For example, number of carbon atoms, number of hydrogen atoms, the more and more position isomers it starts having. Okay, so basically, number of isomers shown by any compound is related with number of atoms it has. Let me give you a quick example. Suppose if we have a C4H7Cl3. Now, how does this compound would be shown? Let me show you. See, it might have all the 3 chlorine atoms here. So how do you name it now? 1, 1, 1 trichlorobutane. Okay, now what we'll do now? We'll take one of the chlorine atom here and we'll attach it here. Chlorine, chlorine, chlorine. Now, what do we name it? 1, 1, 2 trichlorobutane. Okay, so that is the one structure. So we already got a 2 isomer, 1, 2. Now the third isomer. You can have chlorine, chlorine, and chlorine here. How do you name this compound now? 1, 1, 1, 2, 3, 3 trichlorobutane, or you can have like this chlorine, chlorine, 1, 2, 3, 4, 1, 4 trichlorobutane. So that is the fourth. That is the fourth compound. After that, what can we do? We can arrange all the chlorine atom like this. 1, 2, 3. See, 1, 2, 3 trichlorobutane. This is the fifth isomer, right? Then you can also arrange like this. Now, how do we name it? 1, 2, 3, 4. 2, 2, 3 trichlorobutane. This is sixth isomer. Seventh isomer, chlorine, chlorine, and chlorine. So 1, 2, 3, 4. 1, 3, 3 trichlorobutane. So that is how you can name it. Now this will be seventh isomer, and you can just go on. Okay, so basically, as the number of carbon atoms increases, the number of isomers, I would rather say number of position isomers shown by given compound also increases. Okay, so that is one of the things that you need to understand. Okay, other than that, as we progress ahead, you will understand more about the isomerism. Okay, chalo, moving ahead with this now. Okay, so these are the examples of your position isomers and what? Chain isomers. Okay, there are so many isomers that we're gonna see after this, that is position chain isomers, metamerism, tautomerism, and whatnot. Okay, but we're gonna see all of that in the upcoming session. But today's session, that is it. That was the only 2 isomerism that we're gonna see today. Okay, as we go ahead, we're gonna see much and much interesting things about the isomerism. Okay, so yeah, that's it for today's lecture. Bye bye from my side.